So in this video, we're going to learn how to find the critical values for the chi-square distribution. Now remember, we've seen this notation before. When you have chi-square with a little alpha after it, that alpha will be the area in the right tail. And often we'll add in an extra comma with the degrees of freedom. It's not always required, but it kind of helps keep track of what your degrees of freedom is for the problem. Now, the interesting thing about the chi-square distribution is that it's not available on the calculator. You're going to have to do this with the table. So remember, you were given a neon orange sheet in your course pack, and it has the tables for the chi-square distribution and the t-distribution in there. So we're particularly interested in the chi-square distribution because there is no other option. We do not have the ability to go to a calculator. Computers can do it, Excel can do it, for example, but we won't have those options available to us at all times. All right, so let's determine the critical chi-square values for a 90% confidence interval, or corresponding to a 90% confidence interval, and n equals 9. All right, let's start off with the simple thing. We know that degrees of freedom is n minus 1, so that would be 9 minus 1, which is 8. So when we go to the table, that will be the row that we will look at. And then chi-square table. It's actually more of a pain to actually write the word chi-square than it is just to put the little symbol in. Chi-square being its own little Greek letter, and then just squaring it. All right, now we need to know what column we're going to go to. And the answer is a couple of them. See, the thing about the chi-square table is because since it's not symmetric, we actually need two different values. We need one on the right and one on the left, and we're going to need both of them in order to figure this out. So let's see here. We have over here, this area in this right-hand tail is 0.05. Fabulous. Okay, so we know that alpha over 2 is equal to 0.05. Now, how am I getting that? Well, let me back up a second. I know that my confidence level is 90%, excuse me. So that's 1 minus 0.90 to make my alpha, which is 0.10. And then I cut it in half to get my alpha over 2. So I know that alpha over 2 is 0.05. Right, that's one of the columns, right? Column number 1 in table. But remember that it's always giving me the area in the right tail. So if I look at my table, for example, it says the area to the right of the critical value, very clearly up at the top. So I know I've got one at the 0.05, right? And I know I'm going to go to degrees of freedom is 8. So I know the right-hand value is 15.507. But I put a line down the middle of this table for a reason, that thick black line, because all the values over here on the right of that line are on the right side of your chi-square curve. And all the values over here are on the left. So we need another value that would give us that left-hand value. And they've drawn lovely pictures for you here, and you can see that what you're really doing is this bottom picture down here. You're doing a two-tailed item, where you have alpha over 2 on the right side, and then you have another alpha over 2 over here, which means 1 minus alpha over 2 is what you want. It says right there, the area to the right is 1 minus alpha over 2. So let me see if I can clarify for that. When you look at this lovely picture right here, you can see that the area, look at the right-hand chi-square. The area to the right of that is 0.05. Pretty straightforward. But if you look at the left-hand chi-square value, the area to the right of that is that whole white region in the middle plus that gray tail over there. So together that makes 0.95, or in other words, it's 1 minus alpha over 2. So 1 minus alpha over 2 would be 1 minus 0.05, which would be 0.95. And that would be the second column of your table. So column number 1 is pretty straightforward. It's just 0.05. Column number 2 is 0.95. And if you look back at the table, you can see it in the top hand values. See how all of these values over on the right, these are small, like 0.05. And then over here on the left, they're all really big values. And the reason being because, of course, if you're on the left-hand side of this curve over here, then the area to your right is going to be rather large. That's why it says 1 minus alpha over here, alpha over 2 down here. Now, another way you can see it is there's a symmetry to the table. The chi-square curve doesn't have symmetry, but its table does. So you have 0.05, 8 degrees of freedom. So you notice that this 15.507 is one column away from the center line to the right. So go one column away to the left, and there's your other value. It's the 0.95 at 2.733. That would be your other chi-square value. Crafty, huh? That's why that line down the middle is so handy, so useful for us. Okay, so let's go type those up. And there we have the two values. So it's a little strange, but the 0.05 one is actually the one on the right over here. So that's 15.507. And then the one on the left is actually corresponding to 0.95, because that's 0.95 to the right of it. And degrees of freedom is still 8. And that would be 2.733. And all of those, or both of those values, are coming right out of the table. All right, now what about a 0.995 comma 17? All right, well, I'm just going to kind of break this up a little bit here. So if I have 0.995 to the right, that means that you're going to be on the left-hand side of this curve. So I have it over here. See the chi-square value over here? So I know that I've got 0.995 to the right of it. I need to think a little bit about what that center is going to be, because it's not going to be 0.995. That was a mistyping on my part. Okay, so let's look at this. The degrees of freedom is given to us. That's what that little comma 17 part means. So we know the degrees of freedom is 17. We're done. That will be the row of our chi-square table. There's no more work to do there. Then we know that the area in the tail is 0.995. So the area in right tail, which is 1 minus alpha, is 0.995. And so that's the column we're going to go to. We're not going to need to go to 2 columns because it actually didn't ask for 2 values. It only asks for one of them, and it's the one on the left. Remember, when you look at this table, all the values on the left-hand side of the table will be on the left-hand side of the curve. And all the values on the right-hand side will be on the right-hand side of the curve. And they want 0.995, which is this far, far left column. And they want degrees of freedom is 17, I believe. That would be 5.697. Let me go back and double check. Yep. So let me type that up. All right. Now that was pretty straightforward, but it gets a little complicated when they talk about what confidence interval would this use. So let me highlight these real quick. So we know that these answers are our critical values. That's wonderful. Now the confidence level, if this area and this tail is 0.005, in order to make all of this 0.995, right? So let me put it this way. The area in the left tail is 0.005. That's, so the area in the right tail could be 0.995, that whole big white region and that little tip over there. All right, so if this is 0.005, and then the other side was 0.005, in order to make a confidence interval, you need 2 tails. So then the center would have to be 1 minus the 2 of them put together. So 0.005 times 2, 0.005 times 2 is 0.01. And then 1 minus 0.01 would be 0.99. So it'd be a 99% level of confidence. There we go. So I typed it all up just so you can see. So you take 2 tails of 0.005 each. You multiply it by 2, right? You add, and then you subtract it, excuse me, from 1. That gets you 0.99. So your confidence level will be 99%. All right, what about letter C? What if I tell you that alpha is 0.02 and n is 25? Then what would be your critical values? And then what confidence level would use that critical value? All right, so I've already drawn a picture here, but let me see if it makes sense. Alpha is 0.02. That means that alpha over 2 is equal to 0.01. And that means 1 minus alpha over 2 is 0.99. That's a lot to get out. Right, so here, wait on that one. I'll put it right here. All right, so one column is going to be 0.01. That's column number 1 of your table. Actually, this one, there was only one column. And then the other column will be the 0.99. There we go. So 0.01 is column number 1. 0.99 is column number 2. The row we're going to go to is our degrees of freedom. And degrees of freedom is n minus 1. So since they told us n was 25, we know degrees of freedom would be 25 take away 1. So let me go put that in there. 25 take away 1 is, n take away 1, which is 25 take away 1, which is 24. So that's the row we're going to go to in our table. All right, pretty straightforward. So let's go to those two columns and grab those two values. So go to the 0.01 column and the 0.99 column, and we want the 24th row. So I get 42.980 and 10.856. And don't be shocked, they're huge. I mean, the chi-square distribution gets quite large, especially over here on these ends with these large degrees of freedom. So don't be surprised by that. All right, so I'll go type up those two answers. There we have them. And notice that the center must be 98, because if your two tails are each 0.01, 0.01 and 0.01 for the left tail and the right tail, then that would leave you 98% in the middle, and that means that would be your confidence level. Okay, so now we know how to find the critical chi-square distribution values. And again, remember that when you find one on the right-hand side, it would be over here. Right, so 0.0124 was 42.98, and its counterpart is right over here, 10.856. There's kind of a symmetry to the table. Or you could also just say 0.99 and 24 was your degrees of freedom. Now, if you're given a degrees of freedom that is not one you have in the table, let's say like 52, then I would suggest you just use the degrees of freedom that's closest to the value. So, and use regular rounding. So if it was 52, you just use 50. If it was 57, you'd go with 60. Say. There are a couple of different ways you could do it, but that's the way we'll do in our class. All right, we're all done with that, and now we know how to find chi-square distribution values. Make sure that when you draw these, you're drawing them as skewed right. These are not normal curves, and you should not draw them as such. You really need to have it so that it has a kind of a longer tail on the right-hand side. All right, I'll see you back here for more tutorials.